quizzes sort of independent. That's
Yeah, these diagrams. So this is the structure of a quiz. I'll give you a Java program, and you'll create the memory diagram. Not for the main method. So the main method, we won't draw the stack frame at all. It's just implicit that anything outside of all stack frames is in the main stack frame. So all method calls share the same stack, but we separate the stack into portions using these stack frames, using these boxes. So multiply by 2, this stack frame and these variables are on the same stack, but they're in different stack frames. So the stack is a stack of stack frames. Yeah, you only have to mention the, yeah. Yeah, there are caveats. I'll talk about that and remind as we go through the semester, but the general rule is any method that's called that you have the code for, you'll draw the stack frame for. For example, print line is a method call, but I didn't worry about the stack frame for that one. Because we don't have access to the code, it's internal to Java, so I don't care about that stack frame. And then anything outside the stack frames are implicitly in the main stack frame. Now the reason we don't do a box around the main stack frame is after multiply by 2, I might declare another variable and I'm going to draw it down here. And it'd be weird to have like a box and then say, oh, this is also part of the main stack frame. It'd just get awkward and messy. So anything outside all the stack frames is in the main stack frame. I think these questions were answered in chat, but let me just make sure. So we can use the variable name inside and outside the stack frame. Darn tootin'. Well, we also have to draw the box for stack frame. Yeah. Yeah, for any method call other than the main method call, you're going to draw the stack frame. Like that box, you would actually draw that box or multiply by 2 on your memory diagram. Question? Yes. Yeah, so if we call multiply by 2 again after this, we would draw a completely separate box. And when we get to the y method, you'll see it'll be a completely separate box down here. Nope, it'll get a whole new box. Okay, so that's stack frames. When this method returns, well, actually, we're still talking about stack frames. When this method returns, we're going to return x. Once we return something, the method ends and returns that value back to the stack frame that called it, following the return arrow. So we follow the arrow, and we're returning x. Look up x inside the stack frame. It's 4.8. So 4.8 follows this arrow and is assigned to num2, just like we have in the code here. When we reassign a variable, we're going to cross out the old value and then write in the new value on the stack. So even if you're using pencil on your memory diagrams, do not erase the value and draw in the new value. You're going to cross it out and then write in the new one. In this way, we're going to preserve history. So we have the complete history of what happened throughout the execution of this program. We don't want to lose any of that history, any information from the method, from the program call. When a stack frame ends, well, first of all, stack frame lives and dies by its method call. When that method is called, stack frame's created. When that method returns, the stack frame dies. That stack frame is destroyed. It is actually removed from memory. And when we delete a stack frame, all variables that are inside that stack frame, the parameters and any local variables that were declared during that method call, are all removed from memory. They're all destroyed. And then the actual physical location where these values were stored in memory are going to be reused by the next things that we put on the stack. To show that in our memory diagrams, we're not going, just like variables being values updating, we're not going to erase it, but we're going to cross it out to say this stack frame is no longer in memory. It no longer exists. There's no remnants of input or X at all after that method is called. Or after that method returns. So we cross it out to say that stack frame's done, that method call's over, it returned its value, and this arrow technically shouldn't exist. It should just be down here at this point after the stack frame ends. And we can print our new value. Now when we look up num2, again, we're not looking through the code. It'd be an easy mistake to make to look at the code and say, well, num2 is 2.4, so that's what this is going to print out. No, num2 is 4.8 at this point. It's easy to see when we have the memory diagram. You just look it up in the stack and look up its value. And that's exactly what the computer does. It doesn't reevaluate anything. It says, what's the value for num2? Let me look it up in what I wrote down in memory. It's 4.8. That's what's going to be printed to the screen. And we have our silly method call that doesn't really do much. But this Y method, another stack frame, another method call, so we get another stack frame. Put the parameter, all the parameters on the stack equal to the values of their arguments. There's only one parameter for each of these method calls, but if it were a whole parameter list, we would add all the parameters with all of their arguments on the stack inside that stack frame. This method does take an input, but we don't use it at all. Even if we're not using it, we'll still draw it in the memory diagram. I won't do that on a quiz, but for the lecture example, I just wanted something in this stack frame, so I threw something in there. On the quiz, I'll give you a parameter and actually have you use it, so you won't have to. You won't be in that situation. And this method is only called for its side effect of printing to the screen. It returns void. Since it's not returning anything, there's nothing being assigned to the return value, which isn't, nothing is even there. We simply don't draw a return arrow. If you were to draw a return arrow, where would it go? I don't know. I've seen some students, which I see where they're coming from, draw the return arrow to in out when they have a method like this. Makes sense. I see the logic there. But for our convention, we're just not going to draw any arrow. So it prints to the screen, stack frame ends, the method call ends, cross out the stack frame. Don't forget to cross out your stack frames. It's a really easy thing to forget. You're doing your quiz. There's so much you're trying to remember as you're going through the diagram. It's an easy thing to forget. If crossing out your stack frames is the only mistake you have, I'm probably going to give you credit anyway. But try to not forget, because if you have that and several other mistakes on there, it can start tipping you into the range of not passing the quiz. So try to remember, cross out your stack frames. Every method call creates a stack frame, yes, including the main method stack frame. We don't always draw them on the memory diagram, but they do always exist. Do we have to draw a memory diagram on paper or use some sort of software? Good question. Probably on paper. We are in the process of developing software for it. I don't see that happening, being ready to go live to hundreds of students by week 5, which is the first quiz. I don't see that happening, but I do in select labs want to start beta testing that throughout the semester. So most likely it's all going to be pen and paper this semester. Eventually we want the software because it's kind of a pain doing pen and paper. Not necessarily for y'all, but on the grading side, I got all these papers. I got to get them to the right TAs and get them from the right TAs. It's a pain. Couldn't find the lecture recording for this class. I don't think they're on YouTube yet. I haven't talked to the TA who does that yet to get on the same page, and I think I forgot to give him access to Panopto so far. But if you're looking for the recordings, I haven't double checked if they actually did record. Can anyone confirm? Do we have Mondays and we do? Good. So if you go to UB Learns, there should be a classroom recording button somewhere. I haven't looked for where it is on Brightspace. It might be different now, but there should be something that says classroom recordings that's going to take you to Panopto, and then you can watch the videos there. But they're not on YouTube yet. Okay, and once we hit the end of the main method, the program ends, and technically everything is deleted from memory. Stack space is completely wiped. Heap space is all wiped. Everything is gone after that. We're not going to cross everything out at the end of the program. because it's just implied that the program ended. But now, after we go through that, after we trace through all this code in our memory diagram, we have a big snapshot of everything that happened throughout the execution of that program. And then this is what you would submit for your quiz. The TAs can look at this to see that you did fully understand how this code executes. As long as you have all the pieces there. We can't get the timing things. We're not watching you do these memory diagrams, so we don't know if you did everything in the right order necessarily, but it's a loss I'm willing to just take. If you have the snapshot looking the way it's supposed to, you're going to get credit for that quiz. Yep. Yep. Every Java program starts with the main method. Yep. So we haven't done memory addresses yet. That will come up. We'll talk about that starting kind of Wednesday, but really in depth on week 4. For global variables, Java doesn't have global variables, so we don't have to worry about that. Our closest thing we have to a global variable is what's sitting in the main method, in the main stack frame, but even that's not quite a global variable because we can't access them from other stack frames. Yeah, if you just hand in a blank memory diagram and write, well, the program ended and everything was deleted from memory, I don't think you'll get credit for that, but you can try. Will you bless our code also? I don't know if that's directed to me. I think I missed something. Are we going to get to Java loops and conditionals today? Yes, we're doing that right now. We got through conditionals, and we got to the memory diagram of loops in the other lecture, and it looks like we're on track to do the same thing here. I did mention that, right? Next Friday, I added this Java examples. This is just a catch-up day, so when we're behind on slides, I'll do anything we didn't get to on Friday, so I'm not concerned that we fall behind. I usually get really nervous, and I make sure we're always on time. I added this day, so this is kind of planned being behind, so I'm not actually behind. And then we'll be on track for unit testing, and all the lectures for the rest of the semester are timed much better than these first ones, but I had to add a lecture because I always rush these first ones a bit too much. So don't sweat it if when we're getting a little behind here. I ain't worried. But I always like to be on track. I'm very particular about that. Nothing was more, well, I shouldn't say nothing, but an annoying thing when I was a student, we'd get to the end of the semester and the professor would say, well, we got 2 more weeks of content in the schedule, but we don't have time, so we just won't cover them. I'm like, well, why are they on the schedule? Why are they even part of the course? I will stay on track. But this is all by design at this point. All right, loops and conditionals. Conditionals and loops. So I don't have a ton to actually say about conditionals and loops. I'll say a little bit about each, but you really know these concepts from 115 or any language that you're coming from, any CS1 course you're coming from. You know what conditionals are, you know what loops are. So I'll talk about a couple Java-specific things. Here's conditionals. For those of you who aren't coming, actually, everybody should have seen this, right? Even if you're not coming from 115, where you saw JavaScript conditionals, which had this syntax until you started using for of and for in. If you came from any other language, you saw loops like this, or conditionals like this already. But anyway, the syntax is a little bit different from Python. If you only remember Python, we do have braces for our code blocks. So braces to define each thing, not indentation, but everything else works the same. And it's else if instead of elif for what it's worth. It's one thing that bugs me about Python. They're very verbose about everything and use plain English words. And then else if they have to squish into elif. Every other language does else if. I don't understand that one thing about the language. I think because they didn't want 2 keywords, but why not else if without the space? I don't know. But anyway, it's else if in Java. So I don't have much else to say about conditionals. They're conditionals. You've seen them hundreds of times. So I'm going to take this opportunity to just dive right into another memory diagram. And if you do have any holes in your conditional knowledge, we'll probably cover it implicitly through the memory diagram. But I want to get more practice with memory diagrams out there. We're going to see, well, I guess we won't see 3 of them, but we'll see 2 of them today. The one we already saw and this one. So we're going to start with a method call. And this one's a little different than the ones we saw already. This one, we're going to assign the result, the return value from a method call, into a variable which is being declared on the same line. Now, technically, the right-hand side is going to be evaluated first, and then the machine's going to allocate the variable after the method call. We're going to do it a little bit backwards just for logistics on our memory diagram. We're going to add the variable to the stack with no value, and then put the stack frame on the stack afterwards. And then after the method call returns and that stack frame gives its value, then we're going to fill in the value of result. The reason we're doing that is so we have something for the return arrow to point to. That's the only reason. If we didn't do that, if we didn't write the variable name, where would we send this arrow? I don't know where we would put that arrow. Or we would draw it after the stack frame ends and then draw it down here and put a result down here. I don't know. This makes the most sense to me. This is what we went with, is put the variable name, put your stack frame, the name of the method being called, and then the return arrow pointing to the variable that currently doesn't have a value associated with it. And then when you're done with the stack frame, you can, even if you completely forgot, you can follow this arrow and say, wait, where's the return value going? Follow the arrow. Oh yeah, it's going in result. Done. Is there any reason the temp greater than equals 7 part is different? Yes. A very important reason. It's so I can show more memory diagram stuff. That's the only reason. It's just for a lecture example. If you were writing this code, you would never actually write a method like this where one of the conditionals is set up differently even though it does the same exact thing. You wouldn't actually do that, but I just did it for the lecture example, even though it has the same exact effect. So once we call the method, create the stack frame, get the box for it, then parameters equal to the arguments, put that inside the stack frame, then we're ready to run this method, ready to execute all the code within the method. Score divided by 10. Score is an int. 10, I didn't put 10.0 since I just put 10, 1, 0. This is going to be treated as an int. It's an int literal. So this is int divided by an int. We're going to get integer division. So 10s is going to get just 9, not 9.8. The 0.8 is truncated, and we get just 9 in the tens variable, which is exactly what we want in that. We want the tens digit in that variable. So we got 9 in the tens digit. We're going to run the rest of the code. If 10's greater than equal to 9, that's true. Return A. And once we hit a return statement, the method's over. It doesn't matter if there's 100 lines of code after this conditional. We hit a return statement, method's over, we're returning A. That's it. Stack frame's done, method call's done. We found what we're returning, everything shuts down. So we return A into result. Follow the return arrow, cross out the stack frame. Print A to the screen, printing whatever result is. Result has the value A, print to the screen. Hopefully I can gloss over the print statements at the very least at this point. I would think so. I don't think memory diagrams are too much. They're not too overwhelming, but there are just a lot of little things to remember. So there are things like that where I don't have a ton to say. It's just printing A to the screen. We're going to put it in out. But it is something, one more thing that you have to remember when doing these things. If they are more confusing than I think, please ask questions, let me know. Slow me down. We have another method call now. And here's where I'm really taking advantage of the fact that I know how much room I need for each stack frame. I can put my boxes in. When you're doing your memory diagrams, again, I recommend not putting the bottom line on your box because you don't know how much room you're going to need until that method call is over. Unless you look ahead, basically do the memory diagram in your head and then draw the, just don't draw the bottom line yet. Okay, so same thing, stack frame, name of the method. Even though we're calling the same method twice, we don't have any way that we denote that in our memory diagram. The TAs are going to know. They're going to look at your parameters and the values of your variables and all that stuff. They'll know if you got the right call in the right order and all that stuff. We're not going to have any other way to indicate that. We just put the name of the method again. So they look kind of like the same method call, but these are definitely two method calls of the same method name. All right, going to start off just the same. Score gets 75, tens gets the tens digit, 7. We're going to check if 10's greater than or equal to 9, that's false. So go on to the else if 10's greater than or equal to 8, false. Go on to the next one, 10's greater than or equal to 7, true. Now we're going to hit this case of 7 in the tens digit. And we have a new thing here, a new concept or a new notation, however you want to call it, in your memory diagrams. We have a variable that's being declared inside of a code block. Code blocks and stack frames are two big topics of our memory diagrams. So a code block is any code that's defined by these open and closed braces. Technically, you don't need the braces in some cases. I'm always going to put them in anything I show you for class, anything I put on a quiz. So anything defined by these braces is going to be a code block. Whenever we have a variable declared in a code block, we're going to put it inside a dashed box. So if we're inside a code block and we declare a variable, that variable does behave a little bit different than a variable that's declared outside of a code block. So we denote that with the dashed box, and this is kind of a semi-permeable section of the stack where we can cross this line in some instances, and sometimes we can't cross that line. So we denote that a little differently than a stack frame. Yep. You put dashed boxes inside dashed boxes. Good question. We will get to both of these, but code blocks do go nested inside other code blocks. Stack frames do not. It will be a big point. Week 3, I think, is the first time we see that. If you have a method call inside of a method call, you do not nest the stack frames. They are isolated environments. They're completely independent of each other. But code blocks do interact with each other, so we do nest those. So this is declared inside the code block. And code blocks have the same rules as stack frames. Namely, when a code block ends, every variable that was declared inside that code block is removed from memory. This is kind of intuitive in 115, or not at first. We all first learn programming, we make the mistake 100 times, and then we finally learn and get the intuition. Now we're going to see exactly why that's the case. For example, if you have a variable that you declare inside a conditional, and then after the conditional, you try to return that variable, and it says variable doesn't exist. You say, it's right there in my code. Why can't the stupid computer find it? Yeah, well, it's because you declared it inside a code block, and you tried to return it from outside of that code block where that variable is destroyed. And we'll see more examples of that. We probably won't get to those until next time. Yeah. Yeah. So from inside this code block, I can still access score and tens, for example. Right. Yeah, because once we hit this closing brace, which we won't actually hit in this example because we'll get the return first, but once you hit this closing brace, the variable result is removed from memory. Yep. Yep. Yeah, so in this example, we'll see more examples as we go throughout this semester. In this example, we hit the return statement and the entire stack frame ends, but we will cross out the code block separately and then cross out the stack frame. And on Friday, we'll get to examples where they don't happen at the same time, and we'll see the differences. Yep. The table name? The stack? Yeah, just call it the stack. There is another name for it in like compiler's world, the symbol table, I think. In this course, we'll just call it the stack. Print C to the screen. We do it again. And the last thing I want to point out is that when we have a code block where we don't have any variables declared, we don't have to draw the dash box. And I won't draw the dash box. If you want to, on your memory diagrams, draw empty dash boxes in this first and third method call. That's fine, but there's nothing going in there. There's no point. And the method ends, we'll pick up with loops next time. You were joking. And for those of you who didn't take 115 here, just to make sure this question's fair, Java and JavaScript are not the same thing. They're very, very, very different. But if you haven't done any JavaScript, I got to point that out so this question's fair.